Okay, so on graphing quadratic functions, okay, we are going to graph them and they're going to create parabolas, okay? And the parabolas, okay, a parabola. So my parabola can face up, down, left, right, depending on what's happening. We're gonna focus on up and down today, okay? And a quadratic function means that it has a squared as the highest power, okay? So x squared, okay? The standard form, a quadratic function is a function that can be written in standard form. The standard form is written this way. It is written as y equals ax squared plus bx plus c, okay? A cannot equal 0. The graph of a quadratic function is a parabola, okay? Here is the parent function. A parent function is what we're gonna do. Parent functions, remember we did parent functions with absolute value as well, where we graph the parent and then we shifted it off of that, okay? So parent function is just the simplest form of the function, and it is f of x equals x squared, okay? My parent function would be 0, 0 is my vertex, 1, 1, negative 1, 1. Everything's going to reflect in mirror, okay? A parabola has an axis of symmetry. The axis of symmetry runs through the vertex. So wherever the vertex is, that's your axis of symmetry. In this case, my axis of symmetry happens to be the y-axis, but it's also x equals 0 because that creates a vertical line, okay? So my axis of symmetry in that case is x equals 0 or the y-axis. The lowest or highest point on a parabola is your vertex. So if my parabola is facing up, it's going to be the lowest point. If my parabola is facing down, it's going to be the highest point, okay? They're going to ask you to identify all these things. They're going to ask you to identify the vertex and the axis of symmetry when we graph them, okay? So you're gonna have to be able to tell me. We have 8 slides today because we're gonna graph a lot of these, okay? Now, this says graph y equals 2x squared, compare this graph with the graph of y equals x squared. So we're comparing to the parent function. When it says compare to the parent function, I want 2 things on your homework. I want it drawn out compared, and I want it written in words compared, okay? So I'm gonna start by graphing this first one in black, the parent function. Remember, it's 0, 0, it's 1, 1, it's negative 1, 1, yes? Bless you. And I graph it like this. Okay, now unlike a absolute value function, when it comes to the vertex, it's curved. It is not a direct point. It's not a V, it's curved, okay? Now, what do you think we're gonna do to graph this? What? Go to 2? Why would I go to 2? No. All I have to do is plug in points. I'm going to plug in 0, and I'm going to plug in 1, okay? If I plug in 0, what do you get out? If I plug a 0 into this equation, what do I get out? 0. So my vertex is going to be 0, 0, yes? Plug in a 1. What do you get out when you plug in a 1? What do I get out when I plug in a 1? 2. So my next point is 1, 2. What do I have to do with that point? Mirror it. So I don't need to plug in another point. Do you see how that's going? I can just plug in 1. Now, I connect my dots. I've got my graph. So there it is compared picture-wise. Let's talk word-wise. What does that 2 in front of the x squared do to my graph? What does that 2 on my x squared do in front of my graph? Like any other graph, we talked about this with absolute values. What does that 2 do? Yeah, it stretches it. It stretches it, okay? So compare those 2 things in words then to me. How is y equals 2x squared compared to y equals x squared? Yeah, it's just stretched by a factor of 2. So that's all you would have to say. Compared to the parent function, it's stretched by a factor of 2. Okay? Can you do that? Okay. Let's look at some other ones. Okay. Once again, we're gonna graph the parent function, we're gonna compare it to the graph of -1/2 x squared plus 3. Okay, so parent function is like this again, right? 1, and it goes like this. Okay, now let's talk about some stuff before we graph this. What, in that equation it says -1/2 x squared plus 3. What does that -1/2 tell me? It's,
Flips.
it flips and it what?
It stretches.
And it's not stretching.
It's the opposite of stretching.
Yeah, it's another S word.
Fatter.
It's, yeah, it's getting fatter, so it's shrinking, okay?
Shrinking.
So it's shrinking and it's flipped. So my graph should be flipped upside down, shrinking. What's that 3 tell me on the outside? Your Y, yeah, it's going to shift 3 units on the Y-axis, up or down? Up. So my vertex is no longer 0, 0, it's what? 0, 3. Okay, so we're gonna identify my vertex first. My vertex is 0, 3. So 1, 2, 3, right? Now, I'm going to plug in points. I'm gonna plug in 1 again, because it's easy, okay? So if I plug in 1, I have y equals -1/2 times 1 squared plus 3. What's -1/2 times 1? -1/2, and what's -1/2 plus 3? What's -1/2? 2.5.
No.
Congratulations.
Elle's like, I'm too tired right
I
now.
had chemistry.
So I go 1, and I go to 2.5, right? And I reflect that over, yes? And look. Okay, now, we've graphed it. Now in words, you've basically told me in pieces, but in words, describe how that's compared to the parent function. It's flipped upside down with a, with what? Let's word that a little differently. So compared to the parent function, it's flipped upside down with a shrinking of 1/2, and then the vertex is shifted what? Up 3 units up, okay? So my vertex on this one is 0. Okay, now, we have more to do. I have so many examples for you to do. It's crazy fun up in here. Okay, so far, it's not been hard graphing, yes? Okay, but what happens when our equations are a little bit longer? You know what I'm saying? Okay, we're gonna look at that in just a second, so. Here's some stuff. Graphing any quadratic function. You can use the following properties to graph any quadratic function: y equals ax squared plus bx plus c, including a function where b cannot equal 0. Meaning, if it's in standard form, I can graph that function. Okay? The properties of the graph of y equals ax squared plus bx plus c are as follows. If a is greater than 0, you're flipping, it's going to go up. If a is less than 0, it's going to be flipped down. Now, here's how we can graph them. Okay, there's a lot of little pieces to this, and this is what I meant by there are rules that you have to follow. Okay? Right here, do you see how this says x equals the opposite of b over 2a? Okay? If I want to graph something that's in standard form, because those other ones were pretty easy, okay, this one's going to get more difficult. If I want to graph something that's in standard form, I have to decide, does the graph open up or down first? That's the easy part. It's what's in front of the x squared that tells me if it's up or down, if it's negative or positive, okay? Then I have to decide, is the graph narrower than the graph of y equals x squared? Which we also know how to do, because if it's a fraction, it's wider. If it's a whole number, it's narrower, okay? You guys got that down. This is the next part, the axis of symmetry. This is how you find the axis of symmetry, okay? If the parabola is facing up, my axis of symmetry is found by using x equals the opposite of b over 2a. Also, if it is facing down, it's the same equation. So to find the axis of symmetry, you use x equals the opposite of b over 2a. This is your b. This is your A, okay? So I'm gonna look at those things to find the axis of symmetry, which will also help me figure out where my vertex is. Because the axis of symmetry and the vertex are gonna be on the same thing. The y-intercept is C, so the point 0, C is on the parabola, okay? So this point is someplace on the parabola. C will be on my parabola someplace. It doesn't have to be my vertex. It's going to just be on the parabola somewhere. Okay, so we're going to work on that. Graph y equals 2x squared minus 8x plus 6. Okay, let's start with this. The first thing you need to do is you have to figure out what's your A, your B, and your C. What are your A, your B, and your C? What's A? 2 is A, negative 8 is B, and C is 6. Okay. Now, in order to do this, we have to graph the vertex. To find the vertex, I have to use the axis of symmetry formula, which is what? Yes, x equals the opposite of b over 2a, which is kind of part of a quadratic formula. And this is what type of graph? Quadratic function. See how these things piece together? We're taking a piece of the quadratic formula and using it for a quadratic function. Okay, what is my b? You said negative 8, so that's going to change to 8, right? Over 2 times 2. So 8 over 4 gives me 2, yes? Okay, so x equals 2. Do you know what I have to do with x at this point? To find the, yes, I have to plug it in to find the other point of my vertex. Good, Eddie. So, to find the other point of my vertex, I plug it in. Okay, what is 2 squared? 4 times 2 is 8. Negative 8 times 2 is negative 16, right? Plus 6. What's 6 and 8 added together? 14.
14.
And 14 and negative 16 is? So my vertex is 2, negative 2. That's how you find your vertex and your axis of symmetry. So I've killed 2 birds with 1 stone. So 2, negative 2, this is my vertex, and this is my axis of symmetry. Yes? Okay? Does that make sense? Now, what do you think I do to graph the rest of this? What? Because that's my axis of symmetry. What do you think I do to graph the rest of this parabola? I have my vertex, which means I need to just curve it now, right? So what do you think I do? Just like on absolute value. Yeah, plug in a point. I'm going to choose 1 because it's easy. Okay, I'm going to choose the point that's right next to this axis of symmetry, 1. So if I plug in 1, you have 2 times 1 squared minus 8 times 1 plus 6, right? 2 times 1 squared is 2, negative 8, positive 6. 6, 7, 8, so it gives me 0, right? 1, 0. So what do I have to do with that point? Near it. Parabola. Okay? And technically, this only goes 1, 2, 3, 4, 5. So when I continue this, it would go through 0.6. So I could use that as well as a way to graph it and not plug a point in. I could literally come up here to 0, 6, okay? Let's say this is 0, 6, and I could take this and I could reflect it over 1, 2, 1, 2, and that would also be another way I could graph it without plugging a point in. Does that make sense? So you can do it with plugging a point in that's close to it, or you can do it with what your y-intercept is, okay?
Where did you get this
You mean for 0, 6? Or for this? I plugged 1 in, this point here. When you plug 1 in, you get 2 minus 8 plus 6, 0. 6 and 2. There you go. Okay, so you can plug a point in, or you can just use that y-intercept, which makes life much simpler, okay? So the next one, or the next thing we're gonna talk about is maximums and minimums. Okay, here's the deal. If your graph is facing up, it has a minimum. The lowest point of your graph is the minimum. Your lowest point is also what on your graph of a parabola? Vertex. So your vertex is either the minimum or the maximum, okay? All you're gonna have to do is look at the graph once you graph it and tell me if it's a maximum or a minimum. pretty simple. So if your graph is facing up, you have a minimum. If my graph is like a mountain and it's facing down, I have a maximum, okay? That you can totally handle, I know. So if my graph is positive, there's a minimum. If my graph is negative, it's a maximum. So you can even tell it from the graph before you, from the equation before you graph it. So here it says, tell whether the function y equals 3x squared minus 18x plus 20 has a minimum value or a maximum value. Then find the minimum or maximum value, okay? This is easy. Look at the equation. Is it gonna face up or down, your equation? Up. So is it a minimum or a maximum? Minimum. And I told you that the minimum and maximum are your vertex. Is there a way to find the vertex? How do I find it? Yes, I would do the axis of symmetry. X equals the opposite of b over 2a. So, opposite of b would be 18, and a is 3. What's 18 divided by 6? Trace. Okay, now I take that 3 and I plug it back in to find my other part of my vertex. 3 times 3 squared minus 18 times 3 plus 20. 3 squared is 9, 9 times 3 is 27. What's 18 times 3? 50. 3 and 8 is, that's 54,
It's not just 3 days.
right, so then 54, right? Because 3 and 1 is 3.
I said that, one of the numbers last
Plus 20. 20 plus 27 is 47, right? And what is 47 minus 54? Negative 7, because 7 and 7.
I don't.
So 3, negative 7, 3, negative 7 is my minimum value, right? It is also your vertex, it's both. It's your vertex, your minimum value, and it has your axis of symmetry in there. 3 things with one equation. Beautiful. We like when life is much simpler that way. Okay. The next one we're gonna do is a word problem, because I know you love those.
Yes.
They're Caden's favorite. Okay. So, go-karts. A go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize weekly revenue? Okay, so think about this. If it says maximize, what type of equation am I creating? One that goes down, right? So because it wants to maximize, it wants this part right here to make its revenue, right? Okay, so if it wants that part right there, that means my equation's gonna say y equals negative ax squared plus bx plus c, yes? Okay, so let's figure out how we do that from there. Okay, a go-kart track has about 380 racers currently, yes? Okay. And when they have 380 racers, how many more racers do we want to add? At least 20, but we could add more, right? Okay, so that's gonna be part of my equation. I take the number of people and I add 20 or more, right? Okay, that's gonna be in parentheses, because we're gonna need to multiply 2 sets of parentheses because it's a quadratic function, which means I need an x squared in there someplace, yes? Okay. The other part it talked about was price, right? Right now, how much does it charge? 35. What are we gonna charge? Well, not necessarily. We just know that for every $1 they take away, you have more racers, right? So 35 minus X, because we don't know how many more people or how much more we're gonna limit it. Okay? And that's gonna each equal your Y, yes? From here, is this in standard form of a quadratic function? No, so we need to change it into standard form, meaning we need to FOIL.
Yes.
Okay, something that makes Elle excited finally. Okay, 35 times 380. She's like, this is math.
This one,
Yes,
this one.
I can do this math all day.
She's like, this I can do. 35 times 380 gives me 13,300, so 13,300, okay? 13,300. Then I do 35 times 20x. What's 35 times?
Negative 20, x squared.
700x. And then here I do negative x times 380, so negative 380x, right? And then, yes, now I do negative x times 20x, which gives me negative 20x squared. There's the squared I need, right? Quadratic.
How do you get 200? 700.
Because I did 35 times 20.
Oh,
Okay, now I'm gonna rearrange it in the order I need it in. Does that make sense? So this has to come first because that's my A, right? Negative 20x squared. My B is a combination of these. What's 700 minus 380? 320. So plus 320x and then plus 13,300, okay? So there's my equation, right? Now, if I'm looking for the maximum value I can get out, what does that mean I have to do from here? You have to find your vertex. So we made the equation so that we can find our vertex. And to find my vertex, I have to use x equals the opposite of b over 2a. B is, so negative 320 over 2 times negative 20, right? So what is 320 divided by 40? 8. Are you sure? Okay. 8. Okay, so 8. Now, okay, how can the owner of the go-kart track maximize weekly revenue? Now I have to plug in 8 and I'll get out what the maximum weekly revenue could be, okay? If I plug 8 into this equation, that means I have negative 20 times 8 squared plus 320 times 8 plus 13,3. Okay, 8 squared is 64, right? 64 times negative 20 is negative 1280 plus 320 times 8, 560, good, plus 13,3. So add all those together. And you should get $14,580. So your solution point would be 8, 14,580. So the maximum revenue will be that they drop at $8, basically. Right? Because each X represents 1. Cool. I don't know what's happening that way. Okay, that is the end of this. We shall give some homework.